Good evening, everyone. So you all can hear me now. Okay. So we have organized 3 seminars: biology, chemistry, and physics. So today we are doing the physics seminar from 8 p.m. till midnight, and coming Friday evening from 8 to midnight we are doing biology seminar, and chemistry coming Saturday, that is 14th of May, Saturday evening from 8 to midnight we are doing chemistry seminar. So the main objective of this seminar to revise both 10 and 11 syllabus, all the possible areas, because you are getting nearly 50% from the grade 10 work, 40 to 50% from the grade 10 work for the oral science paper, and you are getting MCQs or essay type or structured essay, you are getting from all three areas. So approximately 12 to 13 MCQs you will be getting from physics in the MCQ paper, and structured essay you are getting physics question number 3 physics, question number 4 completely from physics structured essay, and essay type you get question number 7 completely from physics, 8B physics, and 9B physics, right? So basically essay type you get 3 questions related to physics, structured essay 1 complete question, question number 4 structured essay compulsory question physics, and nearly 12 to 13 MCQs. Therefore, without proper understanding about grade 10 and 11 physics, all the lessons, so you cannot go for A or B pass. So instead of just discussing a seminar paper, so that's why we are organizing 3 separate seminars covering all the lessons. Then only you will definitely improve in this subject, and your marks will definitely improve. And today I have invited one of the very popular and very good A-level physics teacher also as the guest speaker, Sir Mihira Jeevananda. He's an engineer, and he's a well qualified A-level physics teacher, English medium, and he also guide y'all, and he will be discussing a separate paper covering all the lessons, and you can get maximum advice from him also, and it will definitely improve your marks. And actually this majority of the students joining here, I think from my students, more than 75% those who are coming for my regular classes. I have done many revisions, and the last seminar tutor I have shared with you, Sri Javadrapur Educational Zone support seminar, physics support seminar paper. So we have discussed the first 20 MCQs of that paper, and I'll be discussing, I'll take about some time, and I'll discuss some of those important MCQs there, and after that Sir Mihira sir will continue the rest of the seminar, right? So I'll share the screen first. So this paper, now you all can see the screen now. This paper, anyway, I have discussed already the first 20 MCQs in my paper classes for my students, and don't worry, the newcomers, new students, you can I will share the recording with you to get the answers for the first 20 MCQs, right? So I'll discuss the other some important MCQs they are remaining. I'll discuss them first. Question number 20, this paper, Sri Javadrapur Zone 20th MCQ. You all can see the screen now. The most safest position for the switch in the circuit below to off both the lamps at once. Right. Now remember, when you are arranging or when you design a circuit, the most important thing is what? Current flows from the live wire to the neutral wire. This is very, very important to understand. Right. Please mark here, current flows from live wire to neutral wire. Therefore, the switch has to be always connected to the live wire. That's very, very important. Current flows from live wire and then passes through this bulb, and it's divided among this branch also, And again, if imagine if 2 amperes, assume 2 amperes current flowing out. So if they are identical bulbs, 1 ampere through this lamp and 1 ampere through the other lamp. So again, it combine and become 2 amperes. Okay, so current flows from live wire to neutral. Therefore, the switch should be always used for the live wire. So not the answer, try to learn something new from each MCQ, the theory behind this. Everyone should write for the question number 20. The switch is always used for the live wire, not for the neutral. Not for the neutral. If you keep the switch B, you can on only the second lamp. If you keep the switch at D, you can on and off only the first lamp. If you keep, you make it A, B, so this one you can make it C here. I'll make the small correction here. You'll make it C. C, right? So that is at C. So at C you can on and off that only that lamp using that switch. So therefore, to on and off both the lamps, the best place is capital A. You have to use the switch for the live wire. So you can write separately. So make it C here. B, you can on and off only the second lamp. At C you can on and off only the first lamp. At D also you can do it, but it is not safe. It is not safe. It's very important to understand. At neutral wire we don't use the switch. So the answer for the first time this MCQ answer will be at A, first one. Question number 20 answers first. Question number 21. Remember O-level science paper, you get many questions from current electricity and domestic electric circuit, electronics, electromagnetism. Every year there will be a essay type question from electricity, and sometimes they combine electronics and electromagnetism lesson also with this. Therefore, without proper understanding about the electricity and heat lesson, it's very difficult to go for a good grade. Please remember that. Now question number 21, you have to find the resistance. Okay. Question number 21. First you have to get they are asking which gives the equivalent resistance in the correct order respectively. Okay, let's see. First one you have to, if all three are parallel like this, you can get the equivalent resistance 333, the short method, 3 ohm divided by 3. Value of 1 is 3 ohms. How many resistors are there? 3. So this branch you get 1 ohm. 1 ohm. So 1 plus 3, the total ohms here will be 4 ohms. The total 4 ohms. This one you get, just to simply add it, 6 ohms. And this one you get 333, 3 ohms. Value of 1, 3. How many resistors are there? 3. So this is the short method. If there are 100 like this, no need to write 1 over 3, 1 over 3 100 times. Value of 1 is 3 ohms divided by the number of resistors 100. If there are 10, if there are 3 resistors like this, 10 times 3 divided by 10. If there are 20 like this, 3 over 20. That is the short method for the MCQs. So you can write here 1 ohm. So then you get the correct answer. First one you get what is the total resistance? 4 ohms. 1 plus 3 4. So this one you get 6 ohms. The last one you get 1 ohm. So 461. The answer is 4th. Question number 21, answer is 4th. Please raise the hand those who got the 4th answer for the question number 21. How many of you try to get the answer before me, then only your thinking ability is improving. Right. Good. Very good. Question number 22. I'll erase the screen. Question number 22. what is the resistance of the resistor, following resistor. So this kind of circuit, very important. You can put a star. Recently they haven't asked a question like this, grade 10 chapter 19. So you are given the color code brown 1, black 1. So you get here brown, black, black. So the first color band you get 1, brown is 1, black is 0, third one also black. That means third color band represents the number of terminal zeros. Number of terminal zeros, that is a short method. If it is 0, no zeros, you have to keep it blank. If you get here, imagine you get here brown, black, brown, black, brown, then you can write, if it is brown, black, brown, then you can write 100, because last color band 1 means 10. If it is brown, black and brown, then you get here 1, 0. If brown is 1, if it is 1, 1, 0. If you get here red or something, then it's 2, then you have to put 2 zeros. But here it's black means no zeros, 0 zeros. So therefore the answer will be here 10 ohms. What is the original resistance of the 10 ohms here? Resistance equal 10 ohms. And after that you have to go for the tolerance. Tolerance given 10%, plus or minus 10. Right. You can see the screen now. Right. So basically it's right again, it's brown is 1, black is 0, then 10 ohms. So what is the original resistance here? 10 ohms. R equal 10 ohms. Then tolerance, I'll write tolerance will be 10 into minus plus or 10%. So you write the percentage here, that is 10 into 10%. That will be 1 ohm. That will be 1 ohm. Tolerance will be 1 ohm. So resistance 10 ohm, tolerance 1 ohm. Number 1. Number 2, the tolerance. So after that you can find the range. After that you can find the range. Range. How to find the range? 10 minus 1 plus 10 plus 1. That is the range. So that means 9 ohms to 11 ohms. 9 ohms to 11 ohms is the value. 10 minus 1 is 9 ohms to 10 plus 1, 11 ohms. That's how you get the answer. So what is the first step? Find the resistance using the first 3 color bands. Brown is 1, red, black is 0. For the third color band, black is 0 again. So if it is 0, we don't write any zeros here. 10 to the power 0 is 1. Therefore the resistance, original resistance 10 ohms. Then using this, look at the pink one. I'll highlight this silver 10%. Using that we can find the tolerance. We can find the tolerance. I'll highlight with a different color. Silver 10% means we have to multiply this by 10%. 10 into 10% is 1. Then you get tolerance number 2. After finding the tolerance, you can subtract 1 ohm from 10 ohms to find the lower limit. Upper limit will be 10 plus 1. Lower limit 10 minus 1. Upper limit 10 plus 1. Then final answer 9 ohms to 11 ohms. this type of questions so far they haven't asked in oral past papers, MCQs frequently. Therefore, this is also very important for this time oral paper. Right, so what is the answer for question number 22? The answer will be second. I'll underline the correct answer. Answer will be second. Please raise the hand those who got this answer. How many of you got this answer before me? Right, very good. Today actually the meeting 100 I didn't invite much outsiders, so I give the priority to my students. But anyway, if you have any difficulty of network failure or difficult to find join, you can request the recording, no issues. Right. Question number 1 to 20, the newcomers, I'll share the recording after the seminar. I'll send that to the group, right? Don't need to request separately. Question number 23, what is the resistance of the conductor? Very easy. Every year there will be a question from the Ohm's law. Otherwise that will not be the oral science paper. Right? Otherwise that will not be the oral science paper. Every year there will be a question from this. Right. I'll use this white background for the explanation. Right. Let's see this one, the answer now. Question number 23. V equals IR. You can use V equals IR when your data given. Remember my advice, you take a piece of blank paper and later literally you can write all the equations that you have done under physics grade 10 and 11. So there are nearly 50 equations, so the expressions you can write: V equals IR, F equals MA, A equals V minus U over T, momentum, right, power equal work done over time, P equals VI, like that. You can write all the electricity, all the equations, even transformers, the equation. So because when data given, the equation should come to your head, otherwise you can't answer the questions, right? So therefore here voltage will be 12 and current you have to calculate, right? Sorry, current also given 0.5 amperes. You have to find the resistance. Very simple one. Remember, you are getting basic level questions also in the oral MCQ paper. They don't make all the questions very tough. So there are questions those who are going for the SPAS MCQs, and there are questions higher level, higher order of thinking questions those who are going for the APAS also. So this will be 0.5 amperes, and resistance you have to find. Resistance R is unknown, so R equal 12 divided by 0.5. So then you get the resistance 24 ohms. Resistance will be how many ohms? 24 ohms. Resistance will be 24 ohms. So the question number 23, the answer is first one. Please raise the hand those who got this answer. Maybe you might have not done this before, but now you can write, you try to get your answer before me, then only your thinking ability is improving, you will improve. If you already know this, so you can do it quickly. Right, very good. Question number 24. 24. Waves require a material medium for the propagation. Select the waves that require material medium. Material medium is what? Either solid, liquid or gaseous medium. So electromagnetic waves, medium is not necessary. Heat trace means what? These days you are very familiar with the infrared thermometer, IR thermometer. To check the due to COVID, this thermometer became very popular because it's contactless. Traditional thermometer, a mercury thermometer, it's contact. It contact with the objects or your surface of your skin. Therefore, it can spread COVID. So therefore, they can ask, even though it's not given in your textbook, the infrared thermometer, IR thermometer, they can ask that question in the exam. They can give an infrared thermometer and ask what type of rays use here. Right? So the heat rays means infrared rays. So that is also electromagnetic. Transverse waves, there are two types. Some transverse waves are mechanical, some transverse waves are electromagnetic. So please write everyone, transverse waves can be electromagnetic or mechanical. So mechanical transverse, you can write water waves. Transverse mechanical water waves. Transverse electromagnetic, you can write the entire electromagnetic spectrum. Transverse, all the electromagnetic waves are anyway transverse. Therefore, transverse waves you can divide into two types: mechanical transverse and electromagnetic. Please write everyone transverse mechanical, the best example, water waves. Transverse mechanical, best example, water waves. So it's possible, right? It's a mechanical wave, water waves. Transverse electromagnetic, you can write radio, gamma, UV, IR. Mechanical, you can write example, water waves. Water waves. Right. And transverse electromagnetic, you can write radio, gamma, 7 electromagnetic waves you have to remember, right? 7 electromagnetic waves you can remember. Radio to gamma. Radio to gamma, you should know all the waves. Radio to gamma. There are 7 electromagnetic waves, they all transverse. So the question number 24, they ask in material medium. For the propagation, material medium requires transverse waves, because transverse waves can be electromagnetic wave. Heat rays can travel even through a vacuum, because heat of the sun reach to the earth in the form of air. So that one vacuum. Electromagnetic waves can travel through vacuum. Material medium is not necessary. Material medium can be solid, liquid or gas. But it doesn't mean electromagnetic, please write, that is a misconception. Some students think electromagnetic waves can travel only through vacuum. No. Electromagnetic waves can travel through air also. Electromagnetic rays can travel through vacuum as well as through air, or through a material medium also can. Please write that everyone in your short notebook. Electromagnetic waves can be propagated through the vacuum as well as through a material medium. But mechanical waves only through material medium. Water waves, sound waves only through a material medium. Solid or liquid or gas, a medium is a must. So radio, then what is the other one? Microwave, right? Electromagnetic waves. After radio you get microwaves, then you get IR, infrared, then you get visible light. After visible light you get ultraviolet, UV. After UV you get X-rays, and after X-rays you get gamma. So those are the 7 electromagnetic waves. So these 7 you have to remember: radio, microwave, IR, visible, UV, X-rays and gamma rays, 7 rays. So one more thing you have to remember: across the period, I mean from left to right, energy increases. Radio to gamma, energy increase. Radio to gamma, energy increase. Radio to gamma, frequency increase. When the frequency increase, energy also of the wave also increases. And lambda, wavelength, decreases. Lambda decreases. Wavelength decreases. Lambda decrease. So that you should know. And one more thing. These visible light also can be divided into 7 colors. Visible light can be divided into 7 colors. That also you should know. What are the 7 colors? The visible light. This one you get after infrared, you get red here. After infrared, red. Before ultraviolet, you get violet. Then the rest you can write VIBGYOR. VIBGYOR. 7 colors. Once in the O-level paper 1990s, they asked the 7 colors of the rainbow. Right? Some students, they don't know how to write the 7 colors in the rainbow. It increase in order of frequency. Radio to or red, orange, yellow, green, blue, indigo, violet. So these are the 7 colors. So this way what happened? Red to violet, frequency increase. Frequency increases. Red to violet, energy increase. That's why sometimes you can see your smartphone, there's a blue violet filter. Right? Blue violet having higher energy, it can damage your retina sometimes. Therefore, some people, they wear UV protective blue violet filters when they view the smartphone or in front of the screen long hours. So you have to, that also very important to understand here. So basically, how to remember this easily: after infrared, red, that means red has higher energy than infrared. After violet, you get ultraviolet. So therefore, visible light also there are 7 colors. That also you should know. Again, what? Electromagnetic spectrum, there are 7: radio, microwave, IR, visible, UV, X-ray and gamma. And visible light also can be divided into 7 colors. So visible light 7 colors you have to remember in order, and electromagnetic spectrum the 7 you should know in order, and each wave at least you should know one function. Radio, one use. IR, one use. IR thermometers, very popular, because remember this time oral paper at least you get one MCQ related to COVID, viruses, respiratory system, very important for this time all over. And gamma rays you should know one use. So it can be, it depends on situations. Gamma rays can cause the cancers as well as, it may cause cancers as well as, if normal cells exposed to gamma, as at the same time gamma rays used for the cancer treatment, radiation therapy, like that. So each wave you should know at least one use and one harmful effect. So that is question number 24. I explained bit in detail because it's important. Right? Question number 24, the answer is C only, right? They are asking material medium necessary only for the transverse waves. Answer is C only. Answer is fourth. Please raise the hand those who got the fourth answer for the question number 24. Right, very good. Answer is fourth. Question number 25. I'll erase the screen. Question number 25. Very good. Okay, those who have done it. A, B, C, D respectively. Very easy. A, amplitude. I'll write the letters here. A, amplitude. A, amplitude. B, B will be wavelength. What is B here? Wavelength. What is C here? Tau. What is D here? Crest. So then you can easily get the answer. So what is the order now? Amplitude should come first. Amplitude, wavelength. So the answer is second, right? Question number 25, answer is second. Question number 25, answer is second. Question number 26, which wave has the highest frequency? Which wave has the highest frequency? To answer this question, question number 26, you need to remember the electromagnetic spectrum in the correct order. Previous one I told. So best example, left to right, gamma having the highest energy, gamma having the highest frequency. Answer is fourth. Question number 26, answer is fourth. Please write everyone, gamma has the highest penetrating power, highest energy and highest frequency. Everyone write, gamma has highest frequency, highest penetrating power and highest energy and lowest wavelength. Lowest wavelength. Then question number 27, I'll erase the screen. 27th MCQ. Ultrasound pulse took 8 seconds to return. To return 8 seconds, that means for both up and down 8 seconds. Took 8 seconds to return, very important. After reflection from the bottom. Distance from the ship to the bottom of the sea. So there are two methods. One thing you can multiply, how to find the distance? Distance is a common equation, grade 6, 7, 8 students also they know this. Distance equal speed into time. The distance equal speed into time. Distance equal speed into time. So what is the speed here? 1440 into time given 8 seconds. Time given 8 seconds. Therefore, I'll take here 4 seconds. Why? It's because I want to find only the depth. So if you are sending the ultrasound wave from the ultrasound generator, so it's going down 4 seconds. Coming back again is returning 4 seconds. So that's how you get 8 seconds. To return it 8 seconds total. So we assume downward 4 seconds, upward 4 seconds, but I want to find the depth. Therefore, I take only the 4 seconds here. What else we can multiply this by 8 seconds and divide by 2. That way also you can do it. So I'll take only this here. Therefore, I'll consider only 4 seconds here. No need 8 seconds. For both 8 seconds, but I need to find the depth. So until it reaches the bottom seabed, that is 4 seconds. When you multiply this, you get the final answer. It's what the final answer, 1440 into 4. Remember, when sound waves travel fastest through the solid medium, that also you better copy down here. 1440 into 4. You get 5760. 5760. This is the final answer. So answer is fourth. Answer is fourth. Answer is fourth. Right. Question number 27. Answer is fourth. Please raise the hand those who got this answer. So this is the distance from the ship to the bottom. Not for both. For coming back it will be double. But if you multiply this by 8 seconds, there are two methods. So if you only can multiply this by 8 seconds, multiply by 8 seconds, then you have to divide the final answer by 2. Then also you get the same answer. Right, very good. Question number 28. Reflection by the radar incorrect. Incorrect one they ask. Incorrect regarding the reflection by concave mirror. Incorrect one. Ray of light parallel to the principal axis passes to the focal point. Incorrect one is the fourth one. Very easy. Please write here why it is wrong. Parallel one should passes to the focal point. Right? So this one you can see if 1 and 4 both can't be correct. Right? First one is correct. Fourth one is wrong. They are asking the incorrect one. Incorrect one is fourth. Right? Incorrect one is fourth. Question number 29. Which statement true regarding the critical angle? Critical angle means when light travel from rare medium to a denser medium, when light travels from rare medium to a denser medium, from denser medium to a rare medium, dense to rare, imagine from water to air, critical angle always occurs in the denser medium. That's very, very important to understand. Critical angle always occurs in what medium? Denser medium. So imagine here water, here air. If this angle is reaching to the critical angle of what I put here C, what will happen to the emergent ray? It travels along the surface separating the two medium. So what is the angle of refraction now? It will be 90 degrees. When R become 90 degrees, the angle of incidence in the denser medium called what angle? Critical angle. And one more thing you can copy down. Critical angle as well as total internal reflection occurs only in the denser medium. Short method to remember. Right everyone? Critical angle as well as total internal reflection occurs only in the denser medium. Only in the denser medium. Right? Only in denser medium. Rare medium, that will never happen. So they are asking the correct statement about this. True statement. Critical angle. Critical angle of refraction is 90. At critical angle of refraction 90. That is correct, right? Angle of incidence is 90, wrong. Critical angle lies in the rare medium, completely wrong. Please write. Try to learn theory also from each MCQ. Right, everyone. Critical angle lies only in the denser medium, and when angle reach critical angle, R must be 90 degrees. R must be 90 degrees. And that happens when light travel from denser medium to rare medium. What are the conditions for critical angle? Light should travel from denser medium to rare medium. Number 2, critical angle occurs in the denser medium. And when R become 90, the angle of incidence called critical angle. So the question number 29, the answer is first one. This is from optic lesson. My advice now, please go through the optic lesson before the oral exam again. Especially ray diagrams. There are 15 ray diagrams. You will not get all these 15 ray diagrams in one paper, but at least they can ask one question, right? Okay, then question number 30. What is the amount of heat energy produced in an equipment during 4 minutes 3 amperes per hour? So what is the equation for H equals? Look at this is from grade 10 chapter 10. Grade 10 chapter 10. P equals VI. Power equal VI. And there's one more equation, H equals VIT. VIT. If you know the voltage, if you know the time, and if you know the current, you can find the heat generated. Because energy equal power over time. Look at here, energy equal HO energy. So I'll write here energy, HO, heat energy, or energy. So you can this equation you have to remember. What is the first equation? Power equal voltage times current. Number 2, energy equal power equal energy over time. Sorry, this is power equal energy over time. Power equal energy divided by time. So how to find energy? Number 3, I will write energy equal P into T. So you can substitute this here. P is equal to VI here. Look at here. P is equal to VI. Energy equal power into time. So instead of power we can put VI. Instead of power we can put VI for power. Then you get energy equal VIT. Heat energy generated VIT. So that's how you get the equation. Energy equal VI. Instead of power we can put VI because power is equal to VI. P equals VI. I'll highlight that. This is from grade 10 electricity lesson. VIT. T for time. We have to be very careful. Time has to be in seconds. So what is the voltage? 230. What is the current? 3 amperes. Time 4 minutes you have to convert into seconds. That's a must. So 4 into 60. Why 60? To convert into seconds. When you simplify this, you get the final answer. What is the final answer? 230 into 3 into 4 into 60. 165,600. Answer is first one, right? You can do the calculation. Remember, oral paper calculators not allowed. Periodic table is not given. Tipex or the correction fluid not allowed. So therefore you have to do it manually, but you will not get many calculations like this. Few calculations you can get, but anyway they will not give very complex one. So the first question number 30 answer is first one. Question number 30 answer is first one. Please raise the hand those who got this before me with the equation. Remember, if you are getting a question like this in the essay or structured essay, you will be given marks for the method also. Equation, now this kind of question, oral marking, they allocate 1 mark for the equation. Oral marking, 1 mark for the equation. Right? 1 mark for applying values to this equation, 1 mark for the final answer. Therefore, don't just write only the answer. Some students, they are doing the rough work with some like separate paper, they do the calculation, simplify and just put the answer. If your final answer go wrong, 0 marks. Therefore, always, whenever possible, write the equation, apply the values with units. That is the other most important thing. Right? Certain parts, or if you don't write units, you will not get the correct unit for the final answer. Then you lose marks. That's also very important. Right? Anyone still copy down? Done? Shall I erase this? Anyone still copy down? Please raise the hand. Done, right? Okay. Now it's 8:50. I will do the last 10 MCQs later. There are 31 to 40. Yeah, I'll discuss them at the end. I will hand over now. I will invite and essay type questions also I'll discuss. But anyway, after the 3 seminars, if I get free time again, I'll try to do some revision with y'all. Now I will invite Sir Mihira sir. Actually last few years also he joined with us for the final seminars for the oral students, even 2019 2020 oral batch, and many students benefited from his teaching, and he's the A-level advanced level physics master, and he has he's the product of Moratuwa, University of Moratuwa, and I have shared his tute. He's the one he is going to discuss today, covering all the grade 10 and 11 lessons. So he has selected some important questions from that. Because there's a separate one. This one consists 24 pages, right? This one consists 24 pages. Therefore, he has selected some important questions to be discussed first. Right? So he'll discuss these ones, and he will tell the question number, and then you can refer that through the PDF or your soft copy, and he will use the whiteboard and explain. So I will invite Mihira sir now. Sir, I think you are there. Yeah. Mihira sir, you can hear me?
let me to unmute from this end as well. And I will share my whiteboard. Yes, dear students, and let me to thanks Priyanka, and I'm going to discuss selected questions. That selected questions also I took into a separate paper that would be easy for you. Then I hope that is shared among you all. And there was a lengthy paper within the time limitation. I selected those, but if anyone interested regarding the full decision, when I have the recordings, I will share to the Priyanka so that you will able to take from there. Okay, good. Without wasting much of a time, so let me to start. I know you would be definitely having your uh, O-level exam now. It is confirmed. So I'm going to discuss the area you will be getting the familiarity with the question that you're supposed to know for your exam to enhance your results. Okay, good. And even if you go through the paper, I selected those sections, especially the magnetism, electronics, electricity area, relatively more than the other areas, simply because even I got to know the many students asking clarification from those areas. It was the simplest reason I took bit more from that area. But anyhow, I will start with some mechanics questions as well. So the very first question, it says, what is the unit of momentum? So what is momentum? You know, when we have a force, force can generate, not the momentum, son, it is a moment, right? Force can generate a moment. How? So if you are having a force that can create a rotational effort, we call moment. It is a rotational effort. And we have another similar word. I don't know whether you have used it. It is a torque. The torque moment. We have same meaning. And it is the rotation would be taken place about a certain point. The moment would be given definitely out of a certain point. We call about a certain point. I would say that point as A, just to tell you. So there would be a distance from the point about which it is rotating, say it is x. The product of those two, what is it? Force and perpendicular distance to the line of action. This is the line of action from the point of rotation. And the product of those two we call moment, x into f. And here it is regarding the unit. How we take the unit? This is in terms of Newton. That is the SI unit for force. This is meter. But how we write it? Newton we would be writing first. And thereafter it is M. So later you will learn there are rules in this. Why we write in first. You know, we have standard method of writing. If you write MN, that is wrong here. Why? This become millinewton. Now we suppose to write Newton meter, Newton in first, thereafter meter, Newton meter. So here answer would be the third one. Question number 2. What is the pressure exerted by water at a point located 2 meters below? Say this is the water surface. 2 meters below, I have a point A. This height, 2 meters. So what is the formula to write the pressure due to this liquid height? P equal H rho G. H, 2 meter. Rho, otherwise you might have used letter D or rho. This is the density. Density of this liquid, it is the 1000 because they have given take the density of water as 1000 into G, it is 10. And I can write 2 and 4 zeros over 20, 0, 0, 0. What is the unit? Newton per meter squared. It is a pressure. So this is, please understand, this is the pressure due to the liquid height. But if we take the total pressure, we should add pressure from the atmosphere. That pressure also to be added to the value if they say total pressure. Pressure would be nearly 1 into 10 to the power 5. We call 1 ATM. 1 into 10 to the power 5, it is Newton per meter squared. Otherwise, this is Pascal, right? Pascal, PA. Question number 3. Consider an object A which is kept on a smooth flow surface as shown in the figure. Two horizontal forces of 50 Newton and X Newton are acting on A as shown in the figure. If the object is moving in a direction of X with a resultant force 10. Resultant force given. You have to that direction X Newton and to the opposite side 15 Newton. And there the resultant force 10 Newton. Now what is the relationship? So if you have forces to that side, X, and it is to the opposite side, if you are having it is to the opposite side, you should subtract it, minus 15. That will be the total. And that resultant, that total, they have given as 10. Again, I am considering the forces to the direction of X, positive direction. They have given the resultant force, it is 10. It is 10. Now I am having X, 15, it is to the opposite. If I had it to the same side, I would be adding. Now it is to the opposite, therefore I am subtracting. Now that net value, resultant value to the X direction, it is 10. Now how much is X? Now an equation is developed. Simply take it to the other side. 10 plus 15, which is equal to 25 Newton. On a horizontal ground, a point B is located to the east of A and point C is located to the north of B. Now let me to mark these points. B is located to the east. And it is on a direction with the direction. North direction, east, south, and west. Now let me to mark those points. B is located to the east of A. A is here. To the east of A, you are getting B. Then C is located to the north of B. North of B. North of B. It is the C. An ant has moved from A to C through the straight line path AB, BC. A to B, this is 3 meter. B to C, it is 4 meter. What is the displacement? And now they are testing your understanding, the definition of displacement. So what is the displacement? It is the shortest distance, right? It is the shortest distance between 2 points, with the direction. You have A and C, started from A. Now it is at C, A to C, with the direction we call the distance with the direction. How to give the direction? I can say from the horizontal, a certain angle, say theta. That angle we can calculate using trigonometry. Don't worry about this at this stage. Yes. This particular distance with that particular direction we call displacement. Right, I need that displacement magnitude. How much is it? This is 3, that is 4. These two together, this will be 90. Now I'm going to use the Pythagoras theorem to simplify this. AC equal, otherwise AC squared equal 3 squared plus 4 squared. This is 9. This is 16. Altogether 25. So it is AC squared. So AC is equal to square root of 25. It is 5 meter. AC equal square root of 25. So it is 5 meter. Now question number 5. A situation where a stone of mass 1.3 kg is at still water in a pond is given in the figure. What is the upthrust acting on the stone by the water? And this is the water. And you will see this. So what are the forces on this? One thing I know, there would be a weight. How much? If the mass is 1.3, the weight will be mass into acceleration due to gravity, it is 10. Now it is 30. And thereafter, upthrust would be acting on this. Upthrust would be acting on this. I don't know whether you have used this word. And there we have a certain theory. It is the law of floatage. Floating. Again, law of floatage. When it is floating, what is the requirement? So you will be having an upthrust. That upthrust should be equal to the weight acting here. The downward forces, it is only the weight. And you will be having certain upthrust. If they are equal, yes, you can keep it floating. Therefore, my upthrust supposed to be equal to 13 Newton. Question number 6. A child of mass 40 kg walk along the straight staircase from a first floor to the third floor of a building which is 9 meter height. From the first flow. The time taken by the child for this entire motion is 2 minutes. What is his rate of doing work? So how much work that he has done? Work done. Work done. Later we can calculate the rate of work doing. Work done. So now what is the work that he is doing? He is climbing the staircase. How much? Height, total height of 9 meters. So as a result, what would happen? We call when you are going up, your potential energy increases. So the work you did would store as potential energy. You are going up. You are going up. Staircase would be like that, right? So it's not the angular distance, right? They have given likewise, you have gone 3 floors total. Doesn't matter whether it's 2 floors or 3 floors. Total height they have given 9 meters. That is the total height. The work done would be equal to the increment of potential energy. We call potential energy increment. Potential energy increment. So how we can write it? MGH. MGH. H, it is the height increment. That is the reason we use the word increment. Right? Otherwise, you can say potential energy, but true, potential energy, even at that position, you have a certain energy, and that has increased. See the increment. Mass 40, G 10, height 9. Even I will keep like this. Yes, this was a joule because this is not the final answer I need. I need the rate of work doing. What is the rate of work doing? Work divide by time. Work divide by time. From there, you have a bit more work, isn't it? You have to calculate work and you have to identify the work be equal to the change of potential energy. And now you are calculating the work. 40 into 10. But if anyone interested simplifying, I don't, it's good, right? But I will keep for the last. So nearly 2 minutes. From there, I hope you know, again, I'm stressing on this. So always when we substitute numbers, we supposed to substitute SI basic units. And later that discussion would come. But don't worry, son, I will tell you, it is your familiar unit. Even for time, you have second, minute, and hour, likewise. Even thereafter days, years. But your basic amount would be the second. Therefore, you're supposed to substitute in second. So 2 minutes mean 2 into 60 second. 2 into 60 second. Here 0, 0 cancels off. 4, 2, and one of the 3, and that 3 and here cancels off. Only 1 3 would remain. That 3 and 10, 30. So what is the unit? The rate of doing this power we call watt. Watt. Otherwise, joule per second. I will write here, son, because that may be the corner. I hope anyhow you can see. Yes, you can see. Let me to give you another similar unit for this. You can write it as 30 watt, same as 30 joule per second. Joule per second is equal to the watt. But there they have given with the 30 watt. Son, can you raise your hand who got this question correct? That's a very good question. Yes, excellent. Yes, good. So compared to the other, did you see that takes a bit more time, right? Because not one step question, two step question. Now question number 7. The movement of an object during 25 seconds is illustrated by the velocity time given. Select the correct statement about the movement of the object. Let me to draw this. So this would be a certain story they are going to tell. This is 10, 20, and 25. Time in second. Here the velocity, maximum velocity reached 10 ms minus 1. Right, let me to read what they say. The retardation of the object is 2 ms I think there would be a small mistake in the print, right? Because retardation, acceleration, and the retardation, that's supposed to be with ms minus 2, right? The unit. So where you get the retardation? So retardation, what is this? Your velocity increasing. When velocity increases, we call that is an acceleration. Here you get acceleration. Acceleration. Now exactly what is the acceleration? The rate of increment of velocity. Otherwise, rate of change of velocity, yes, we call acceleration. But if you are having a negative acceleration, we have a different word for that. Again, the rate of change of velocity, right? Velocity changes. The rate, that means change of velocity divided by the time, you get the rate. Then it is acceleration. When acceleration is positive, yes, again we say it is acceleration. But if you get acceleration negative, we are using a word that is called retardation. Otherwise, deceleration, right? Deceleration, retardation, both when acceleration is reducing. Such a one we call negative acceleration. Now, this is where when velocity reduces, it is retardation. Now that rate of reducing, how much? I need to take the proper way of writing delta V divided by delta T. I don't know whether you have used like this. If you have used V divided by T, yes, you can, but this is the proper definition, right? Now let me use this. How much it is going to use to change from here to there? Finally, it will be 0. Initially, you are having 10. So that much of velocity change. Even when you take the change, and always the final value minus the initial value. This is the final. This is the initial. Divide by, what is the time taken? Finally, you are having 25 seconds. Initially, you are having 20 seconds. So this is the answer to be taken. I wrote the acceleration. This will be minus 10. Divide by this will be plus 5. So I am having minus 2. Unit the velocity ms minus 1. This is second. Now ms minus 2 meter per second squared. And because of negative, we call it is retardation. So retardation. To ms minus 2. Therefore, first statement would be a correct one, but the unit supposed to be ms minus 2. If it is ms minus 1, it is not correct. The displacement of the object is, so how to get the displacement? When you get velocity time graph, the area under the curve, this area under the curve, it is the displacement. This is the displacement. How to find? We found the correct answer anyhow, but let me to do the others. Displacement. It is equal to the area. You have to say properly area under the curve, but I will write in short. So how to find this area? It's a trapezium. Trapezium area, that distance plus here the distance, divide by 2, multiply with the height. From here to there, 25 plus this length, 10 here, 20 here. That will be another 10. 10 to 20. Divide by 2. Multiply by 10. $35 into 5. $175. 35 into 5. This much a meter. They say it is 0. So to find it is 0, it is not 0. I will tell you quickly because this area won't become 0. Yeah, that statement is wrong. Quickly you can find. But if you have to find how much is it, yes, this is how you have to do. The acceleration of the object is 10 ms minus 2. Again, it should be ms minus 2. Let me to calculate acceleration also. This is just to give you a good practice on this calculation. Delta V divided by delta T. Finally 10. Initially, because this is where it is accelerating, right? Initially 0. 10 minus 0. Divide by time taken. 10 minus 0. Why, son? Here is 10. There it will be 0. So 10 divided by 10 is equal to 1. ms minus 2. Because this is ms minus 1. Here is altogether ms minus 2. So it is not 10. The object has moved 20 seconds with a velocity 10 ms minus 1. 10 ms minus 1 going with constant velocity from here to there, right? This length, right? So now, what is the time? Starting with 10 seconds, that is over at 20 seconds. What is the total time duration? Only 10 seconds. Only 10 seconds. Going with 20 ms, 10 ms minus 1 for a time period of 10 seconds. Now it is not 20. So that was wrong. Now let me to move into question number 8. A situation where an image of flower pot taken on a white vertical plate using an using an item called X is shown in the figure. Find following. Which of the following could be X? Can you see? This is the pot. You have kept something here. Okay. And you will see on the screen how that appears. This is how it appears. What are the properties? And it is taken to a screen. One thing, it is taken to a screen. Properties, right? Because otherwise you won't see it. You know, you are looking at this, right? You are looking at this from this side. You can see that. That's what we call it. That can be taken onto a screen. Taken onto a screen. Second, image inverted. Inverted image. Inverted image. Now, what would have been the instrument X? Image can be taken onto a screen. Inverted image would be created with convex lens. Convex lens. They are given plane mirror, no. Convex mirror given, no. Why isn't it won't go to that side? No, if it is a mirror, it's supposed to come back to the reflection supposed to take place, right? Concave lens, no. Convex lens. Convex lens. So considering these two distances, can you draw the ray diagram? So from here to there and from here to here. If you compare with the distance given in my diagram, it's like, right? If I say this is 5 centimeter, this is like 10 centimeter. Did you realize this? This is like centimeter. This is like 5 centimeter. So can you draw the ray diagram for this? Just take the tip of this, one point, where this image would go. Can you draw the ray diagram? Say this is 10 centimeter, this is 5 centimeter. Can you quickly do that? We'll see, because I am going to test another knowledge capacity, whether you can draw the ray diagrams. F distance, 2F distance, optical center, here F, there also 2F distance. So I saw this side more distance, right? That is how I considered. And if so, I suppose to keep my object away from 2F. And we know my image supposed to be in between F and 2F, isn't it? With your memory, we keep in our mind, if it is away from 2F, your final image would be in between F and 2F, right? But anyhow, let me to teach you how to draw the ray diagram. One ray I will draw from top of this, going through the optical center, then it will go straight. That particular ray is supposed to go straight. It will be a ray when you draw these arrows. Arrow, it is a must at both sides. The next one, the ray which is coming parallel to the main axis, that ray would go through the focal point. It will go through focal point. And this is the second ray. Intersection point, I will be getting my final image. It is inverted. Compared to this, that will be smaller. Right? Why I took like this? Because I said, yes, consider from here to there, it is as 10 centimeter, and just a certain comparison, right? And there I wanted 5 centimeter like. Otherwise, if you say X here, 2X there. Just copy that ray diagram. So please raise your hand who could get the ray diagram correct before I drew. Good, good. Question number 9. Which of the following statement is true regarding waves and ice? So you had a bit lengthy discussion on waves. Therefore, let me to finish this quickly. Transverse wave propagate with compressions and rarefactions. So there are two types of transverse waves. Compression and rarefactions, you will see with longitudinal waves when sound travels. That is where compression and rarefactions would occur. Now it is not with transverse waves. Distance between the crest and a trough of a transverse wave is equal to the wavelength. So is it distance between crest and a trough? No, from crest to nearest crest, or otherwise trough to the nearest trough, you will get the wavelength. That was second one also wrong. It is not necessary to have a medium for the propagation of mechanical wave. No, definitely for the propagation of mechanical waves, we need to have, again, for the propagation of mechanical wave, it is a must to have a medium. Otherwise, it won't propagate. Only the electromagnetic waves that can propagate without a medium. Energy is transmitted by mechanical wave without the transmission of substance. Yes. So there won't be a net transmission. Energy is transmitted by a mechanical wave without transmission of substance. Yes, there won't be a net transmission. That is what we call. There won't be a net transmission. Maybe the going up and down, or otherwise going back and forth, but there won't be a net transmission. But the energy is transmitted. The fourth one is correct. So how exactly it is transmitting, we would be discussing later at A-level stage. Not that I hope you are not exactly discussing how it is going, but we know mechanism. Question number 10. When sound wave emitted by a loudspeaker propagates through air, it's while it is propagating, what will happen? Some frequency. Frequency means, and again, read this. When sound wave emitted by a loudspeaker, right, that propagates through air. Propagates through air. Now, while it is propagating, what would happen? What will change? That is the one they are asking. Frequency decreases? Never. Frequency decreases? Never. Why? Remember, son, in a wave, frequency, that is not going to change. Frequency means the time take, or within a second, within a 1 second, how many times it is going up and down, otherwise back and forth. We got number of cycles per unit time. That will be constant. Velocity decreases. That also no. Depending on the medium, yes, it might change. Medium means they have given it is going through air, right? The sound wave emitted by loudspeaker propagating through air, yes. But if it is going through water, yes, that is a different value. But if you get the air throughout, similar air, no change. Wavelength decreases. That also again, no. Wavelength, the distance between two crests, no. So what will? So finally, it says the amplitude. If I plot, even I will show you some with a set model. I will show you what that story is. Amplitude means the way it is going, the height. This particular height. This particular height. That is the one we call amplitude. This height. That reduces. So to make you understand much better, let me to take a different example. Different example. Not that one, right? Not the sound, but I will take. I hope you can see this plumb bob. So what I am going to teach you, that story, amplitude reducing, that is the one I am going to teach you, right? So when, what orientation would be the best thing? If I keep like this, that you can see much better, right? Right. So while it is going, right, there would be a certain distance going on, son. Right? While it is oscillating, can you see a certain distance going? Right? Certain distance going back and forth. Even I can keep a bit closer to the board. I'm bringing up until this. The distance going, that is the one we call amplitude. That is the one we call amplitude. Later in A level, we have a certain practical to calculate whether I keep this much of a displacement, whether I keep that much of a displacement. So you will realize time taken to go one round, it is the same. Now we call time period would be the same. Therefore, frequency also would be the same. But so we call amplitude reducing. What is that story? Initially, I will draw there. Initially, you will realize This is going that much of distance. Likewise, if I keep at the middle, right? Starting from here, it will go to this point, it will go to this point. Yes, initially. But later with time, you will realize this is not going that much. With time, you will see it is reducing. From the middle, it is reducing. So that is the story we call amplitude reduces. Amplitude reduces. Let me show you. See what happens. I'm keeping like this, right? Picking up until that. You will realize what happens with time. I think I did not start from the middle. This is the middle. Yes. See what happens with time. You will realize the total distance going, that will be smaller. Check now. It is like the second line I have drawn. Initially, I had the bigger line. Now it is reducing. Now it will be even smaller. So that reduction, that is the one we call amplitude reduces. So to one side, that distance, here it will be this much. That is reducing. But it's a different example because that particular movement would be different to the movement here, right? But anyhow, it is how is the simplest way of telling. We call this a pendulum. With a pendulum, we can see that easily. Now remember, what will reduce with the time, we call they are mechanical waves. For a mechanical wave, what will reduce with the time, it is the amplitude. Why? So it is because we are losing energy. Why it is reducing? Losing energy. Because our distance would be there, our energy is lost. It is the reason. Now that we have a word, I don't know whether you are using that particular word, that reduction is called dampness, damping effect. Okay, good. Just to, it took a bit of a time to explain exactly what it is. Because rather than learning by heart, it's very easy, son. When you see practically, that will go to your head. Question number 11. The focal length of a mirror is 30 centimeter when an object is kept on the optical axis of the mirror. The image found by the mirror is real and the size is equal to the size of the object. The distance from the mirror to the object is. Son, could if I draw that ray diagram? We know the answer, but can you draw the ray diagram also for me? It is a mirror of what? Focal length of a mirror. When the object is kept same size, you will see only from concave mirrors. Where you need to keep, it is at 2f distance. You keep it there, you will be getting your image also at the same position. How to draw the ray diagram for this? The ray which is going straight would be going through F. And next ray going through F, going parallelly. And you will see it is right below that. Focal length f equal 30. Two times f. This is 2f, which is equal to 60. Now I need this. That is where the object is kept. Inverted. Real image can be taken there. Now question number 12. The following figure ABC are three beams of light using a glass lens. One of three beams can be converted into another type of beam that is shown in the diagram. Which of the following statement is correct? A can be converted to B using convex lens. A can be converted to B. What are the three types of ray diagram they have given? Parallel beam, A. Converging, B. This is called diverging, C. If you keep a convex lens, the first one, convex lens. For parallel rays, it will converge. It will converge. Therefore, A becoming B. Your first answer is correct. A to B concave, not possible if you keep concave lens. This is how it is going. B to A using convex lens. B to A, no. I don't know whether you have drawn depending on the position you keep. If you keep B, this is how the rays are going, sir. You are going to keep a convex lens. And if you keep somewhere there, what will happen? So they would be converging even faster. Therefore, they become dotted lines now. They're supposed to converge somewhere there. It would be coming up until this. C to A using a concave lens. C to A. If I keep concave lens, I will keep somewhere there. What would happen? They would be, this is called diverging lenses, rays. Therefore, it would diverge even more. They would be diverging even more. Therefore, they become dotted now. This will continue as I took it at the middle. Yes. Therefore, first one is correct. All right. Now let me to take question number 13. I will erase the board before that. Right, number 13, on a certain day, the Norelia town, the daytime temperature was 16 Celsius. Theta 1, 16 Celsius. The night time, the temperature, theta 2, 4 Celsius. Right. What is the temperature difference between the day and night in Norelia town on the day in Kelvin? Kelvin. So there, the Kelvin, the way I have written is not correct. It should be simple Kelvin. When you write Kelvin, it is simple K. Remember, it is simple K. So there, because if you write Kelvin, that gentleman Kelvin, but here unit Kelvin, it is simple Kelvin. So how to convert the Celsius into Kelvin? Our Kelvin temperature, I would say with K1, theta 1 plus 273. This is how we're supposed to take. The K2 temperature, if I write there, this one, K2, it is equal to theta 2 plus 273. I need the difference of these two. K1 minus K2. This is the one I need. Theta 1, 273 minus theta 2, 273. That difference. K1, I took from that. K2, I took from this. So now I'm going to give you a final easy method. That is the reason I started doing this. Just to explain. No need to do everything. So can you see theta 1 plus 273 because of this minus theta 2 minus again 273 also minus. Now these two cancels off. Theta 1 minus theta 2 is equal K1 minus K2. That means you can remember always difference of Celsius is always equal to the difference of Kelvin. This is 16 minus 4. It is equal to 12. Either you can write with Kelvin or otherwise you can write with Celsius. It is the same. So when you write just Kelvin, only one K, then it is capital K. If you write in full, then only it is simple Kelvin, simple K. There it is capital. Question number 14. Which of the following equipment is based on phenomenon of electromagnetic induction? Electromagnetic induction means some potential with induce, right? Induction potential would induce. Direct current motor. There what you are doing, sir, you are giving the current, therefore motor words. Loudspeaker, and there you are sending a certain current. It is movement, not the generation of potential. Electric, it says a ball, right? Electric ball. Again, there won't be any potential development due to any movement. Moving coil, magnetic microphone. So what is that? So you will hear my sound. Let me to tell you what type of instruments I have used. So I am talking to what? To a microphone. This is where I get my microphone. So what my microphone does, when I talk, so my in this medium going back and forth. So while it is going back and forth, inside this microphone, there would be a sensitive membrane that is going back and forth. It would generate a potential variation. That is what we call signal. So when a signal is generated, then only it will be going through this wire. Yeah, my sound. Let me show you. My sound, the one I am talking, right? It is generated to a, let me show you my wire. Yes, I took that to a front. So inside the wire, this wire, electric pulse going. So that electric pulse generated by this microphone. Therefore, the microphone exactly what it has done. Movement, it is a mechanical wave. That mechanical wave converted into electric potential variation. We can say it is a wave, electric wave. So that is the one which is amplified later on thereafter. Therefore, the moving coil magnetic microphone that will be generating electro or using the electromagnetic induction theory principle that would be generating a certain potential variation. Therefore, we suppose to select fourth one. Fourth is the answer. Moving coil magnetic microphone. 15th. This is where the fourth one to be selected, right? 15th. The power supplied to a primary coil of a transformer 100% efficient is 200 watt. If the voltage across the secondary coil is 10 volt, you have the primary and it is going to the secondary. How much of power coming here? It is 200 watt. If it is 100% efficient, what would happen to the secondary also? Same power would be transmitted. Same power transmitted to the secondary. Now the potential across this secondary 10 volt. They're asking how much of current going? I. So what is the relationship? This P is equal to VI. Power 200, potential 10 into I. I will be 20 ampere. 20 ampere. What is the equipment that works using the force exerted on current carrying conductor placed in a magnetic field? That we call the motor effect, right? Moving coil microphone, we said it is the opposite, right? Electric, it is not the, it is a bell, right? Electric bell. So what is electric bell? How it is created? Let me to show you the mechanism there. You are having a coil. When current flows, there would be a certain flux going. And if you keep a certain steel part, it would be coming towards this. But only thing how the system is generated while it is moving, your circuit get disconnected. Because it's supposed to be here, then only circuit get connected. I will draw to this. Okay, good. Small schematic diagram. So when magnetism created, this will be going to that side. Circuit disconnected. When it disconnected, no magnetism. Now it will be getting released. While it is releasing, it will hit to this because it is coming faster to this side. We keep that is almost spring loaded. And again, when it comes there, my circuit get completed, current start going, now magnetism creates, then it will be coming towards that side again. When it moves disconnected, no current, no magnetism, now it is coming back. Therefore, this particular will be moving to this side and coming back. Moving there, coming back. And it will hit to this. It will generate the sound. So what I wanted, what is the equipment that works using a force exerted on the current carrying conductor placed in a magnetic field. I suppose a magnetic field separately, sir. There are no such magnetic field separately. Magnetism is created there due to the current. So not electric bell, transformer. So in a transformer, exactly what is happening? There won't be any force generated, isn't it? No force. Direct current motor. Direct current motor. Yeah, that is exactly. Why? You are giving the current. Inside that, you get the magnetism. Magnetism is available. Your coil inside that, externally current giving. Therefore, your conductor is subjected to magnetism inside that. While current flows, a force generated. That is how the rotation created. How it is the direct current motor. Direct current motor. Or shall I draw a diagram for you? You will be having many woundings. Let me to draw one. I would keep a certain magnet here. Another magnet there. You would be sent a current, say north, and that is south. So on this part as well as on that part, you will see forces are occurring. The direction of the force you can take with claiming left hand rule because it is a force. Now it is coming with the left hand. So I want to tell you a story to keep in your mind whether the left hand or right hand to be used, but the wording comes with the singular letters. So this is a motor, right? Motor. The other one we call dynamo. So motor, that is where the rotation takes place when current is given. The other one dynamo. So this is called mo. This is called the dynamo the, right? Therefore, in this word, mo for motor, therefore dynamo. Now, in this word, this is the left and that is the right. This is the left. Now, left hand rule, that is for motor. That is the reason this is in the left. Dynamo, it is the right hand side. Right? Now you have to use the right hand side word, right hand rule for dynamic. The don't interchange. Now let me to take question number 17. So there, quickly calculate before me what I need. The current, what is the current I produced by the cell? The current in the cell, that is the one I need. Six volt, 18, 18. S, P, R, Q. So the easiest way, there are a few ways of doing, but let me to simplify these two. Those two are parallel. Parallelly, I can simplify to a single resistor. What is the method, sir? 1 over R equal 1 over 18 plus 1 over 18. Out of 18, 2 divided by 18, which is equal to 1 over 9. So R equal to 9 ohm. Here 9 ohm. This is 6. Now you can use V equals IR across this. V equal IR. V 6 volt. I R 9 volt. I equal 6 divided by 9, 2 divided by 3 ampere. So tell me who got that answer correct for question number 17. Please hands up. Raise your hand. Good, good. Take question number 18. There also quickly calculate the answer. I will erase the board. An electric lamp bulb of a motor car is labeled 12 volt 0.5 ampere. Consider following statement about those values. To have a lamp, 12 volt and 0.5 ampere. 12 volt and 0.5 ampere. Consider following statement about those values. A. When an electrical supply of 12 volt is given across the bulb, the current through this is 5 ampere. Son, exactly yes. If you give 12 volt across this, how much of current would be going? It is 0.5. That is what that data says. A is correct. When the bulb operates normally, its power. So how to calculate the power? V into I. Potential given, current given. 12 into 0.5, that much of watt. The statement B also correct. The resistance of the bulb. Even there, to calculate resistance, I can apply V equals IR. I know when 12 volt supplied, current will be that much. 12 equal 0.5 times R. R will be 12 divided by 0.5. Now C also correct. C also correct. All A, B, C are correct. So please hands up for that. Raise your hand. Yes, good. Question number 18. Which diagram correctly indicate the connection of 1, 5, 12 resistors so that the equivalent resistance between A, B is 4 ohm. So what you have to do? You will have to simplify each one. You will have to simplify each one and find where you are getting 4. You can simplify this first. These two are parallel. I can simplify that into one single resistor. Sorry, these two are series, right? That one I simplified. Thereafter, these two are parallel. 1 ohm, 5 ohm. Here, 12 ohm. 6 ohm. These two together, 6. You have to add them. This will be 12 ohm. 6 and 12, I need to take the resultant. They are parallel. When they are parallel, 1 over equal 1 over 6 plus 1 over 12. Reciprocal addition. Out of 12, this will be 2. Here it is 1. Therefore, 3 divided by 12. 1 over equal 1 over 4. Therefore, R is equal to 4 ohm. Then that is the one I need, right? Anyhow, let me to simplify others as well. Three parallel resistors. 1 ohm. Second one 5 ohm. And 12 ohm. All three parallel. 1 over R equal 1 over 1 plus 1 over 5 plus 1 over 12. This is how you have to simplify. Now you have to take out of 60. 60 plus 12 plus 5. Out of 60. 77. 60. It is 1 over. The R equal 60 divided by 77. if you want to do this, tell me how you are going to simplify. 5 for this, 1 for this, and 12 for that. First stage, as I did before, 13, the addition, here 5. Parallel, 1 over equal, 1 over 13 plus 1 over 5. Out of 65, 5 plus 13, 18 divided by 65, R equal 1. 65 divided by 18, because you are reciprocal. So we found the answer. I just did this just to show you how the simplification would be done. My numbering 18 is 2. This should have been 19, right? Yes, this should have been 19. And then the 20th. 20th. An alternating voltage was subjected to full wave rectification followed by smoothing by a capacitor. Which of the following graph illustrate the variation of output? Son, shall I draw the diagram for you? Because there would be a set electronic circuit for this to achieve. Let me to draw that diagram as well. So this is how you have to start, right? Full wave rectification using diodes. You draw a diagonal, right? In this diagonal, use your diode starting from this side to that side. This is the proper direction of current through the diode, right? Take to this side. And here also to that side. And these two terminals, take it for the input side. You have alternative current input. From these two, the other two, you can take it for the output. Then when you take the output, we would be fixing smoothing capacitor. This is a capacitor. This is the resistor. Output is taken from there. That is the input. You would be getting such an alternative waveform input. Your output would be after doing the smoothing. And before doing the smoothing, it would be like this. After smoothing, we get in this form. V out after smoothing. Now that is the diagram we wanted. So now MCQs are over. Let me to move into part A questions. Consider the following type of waves. What they have given: ultraviolet rays, infrared. Infrared would be having smaller frequency than the red color. Microwaves, even you might have seen microwave oven, right? X-rays, gamma rays, visible light, sound, ultrasound, sound waves and ultrasound waves. Right? They are giving few. Of the above waves, mention a wave that propagate with compression and rearfractions. So where you get compressions and rearfractions with sound waves and ultrasound waves. So what is the difference between sound waves and the ultrasound? You might have heard ultrasound scanning. Ultrasound scanning. So sound wave, when I talk, if you are in front of me, you will get the sound. That sound we call a sound wave. So in ultrasound, the frequency would be very much high. And I hope you know our audibility, or otherwise audible range frequency from 20 to 20,000. We can hear to our ear, right? That is our range. If you get frequencies beyond 20,000, we can't hear. But there are some animal, they can hear it. But such frequencies beyond 20,000, we call ultrasound. The ultrasound, 100% similar to the sound, but only thing we cannot hear as frequencies high. That is the simplest reason we cannot hear frequencies high. Such thing we call ultrasound. The ultrasound waves we will not able to hear, but they have compressions and rearfractions. Write down a special characteristic of ultrasound waves. What is the special characteristics? The frequency is high. High frequency. Higher than 20,000. Next. In the field of medicine, which type of above waves is generally used to observe the condition of a fetus inside the womb of a pregnant mother. So there, what is really important? So we should not get any harm. Lot of scanning without harming the body, we can do with ultrasound scanning. But there are scanners with X-rays. So X-ray scanning that can damage our body because the X-rays are going. They are damaging our body. But the ultrasound, of course, zero damage. Zero damage. Part for electromagnetic spectrum is given below. AB, visible light, ultraviolet rays, CN, gamma rays. Now, what these things are, even I could hear, you must know this, right? Yes, what this. A, B, visible light given. Just after visible, ultraviolet, and X-rays. This is the one with C letter and gamma rays. What is A and B? Visible light, this is visible. This corner it will be red. Anything lower red, infrared. Infrared. So below we would be getting microwaves. Here microwaves. And thereafter you get TV and radio. This is A. Here B. This is C. A waveform relevant to a gamma ray is given below. A trough is taken, crest. Gamma ray. What they asking? By which name R of the wave can be identified? It is a trough. It is a trough. It is a trough. Then, which physical quantity of the wave is equal to the distance between point P to Q from here to there? That length is the wavelength. It is the wavelength. So wavelength can be measured even from here to there. Or otherwise from one crest to the nearest, one trough to the nearest trough, or from crest to the nearest crest. Consider the features of the wave form given above for a gamma ray. Draw a typical waveform in a following grade. The type of wave represented by C. What is C? X-rays, right? in the spectrum above when amplitudes are equal. So what is this? This is a gamma ray and this is a X-ray. What is the difference? Frequency, this will be higher, that will be lesser. That will be lesser. What if I had another color to draw on this? Why? And if you take a time, this is the time period. This is for gamma ray. This is for gamma. But the time taken for one round of X-ray would be more than this. Would be more than this. Something like this. Now, if I draw separately, what would have been the difference? They have given the scales. If you see there, it will be almost more than 20, more than 12, like, right? One round, it is 12 small divisions. Therefore, the next, it's supposed to be more than that. Something like this. The distance will be more. Next one. It is the fourth part. Oh, sorry. It's the fourth part, correct, yes. Of the sixth wave given in the electromagnetic spectrum above, which has the highest frequency for gamma, right? Highest frequency for gamma ray. Question number 5. A diagram depicted two instances of P and Q of a activity done by the laboratory to study a certain characteristic of sound wave is given below. A chuck saw blade is kept on a table and heavy metal block is kept on the blade. When this activity was done as shown in the figure, then the table was vibrated. Which characteristic of the sound wave can be studied from this activity? Can you see the difference of those two activities? One longer, the other one shorter. Let me to read 3 questions. Which characteristic of the sound wave can be studied from this activity? On which physical quantity does the activity you mentioned above depend on? What conclusion can be arrived at through this activity? So what is the difference in these two? One shorter, only smaller length is thick. So it will be vibrating that much. The other one longer. The other one longer. So there would be a certain characteristic. when it is shorter and when it is longer, we would be having two properties. The one we call it is the pitch of this and pitch of the other, pitch. So what is the difference? We call here, it is at high pitch and this would be at low pitch. Now that pitch will depend on what? Number of round that is going here per unit time would be more on this F1. But on the other, the number of rounds that will be going on this, that will be lesser. So they ask in the second part, on which physical quantity does that characteristic mentioned above depend on? It is the frequency. Now what is pitch then? So the way you hear those two sounds, you will see a different. That different is the one we call pitch. Pitch property that will depend on the physical quantity of frequency. Here you get high pitch, there you get less pitch. What is the difference? Yeah, I said the frequency is more, right? F1 greater than F2. When frequency is high, pitch would be high. You have to say frequency, right? I will just say is high. Pitch is high. When frequency is high, pitch is high. How does the speed of the sound in air vary with the temperature? So I don't think you are calculating any formulas, because formula calculation would be during the A-level scope. We have formulas, but you should understand one thing. When the temperature is high, speed of sound would be high. When temperature is high, speed of sound is high. Remember that. Of course, we are using the absolute temperature. Absolute temperature means the temperature you are writing with Kelvin. That is the temperature to be taken, right? When T is high, F is high. So no need to know at this stage, at O-level stage, but later I will give you your sound speed can be written with this formula. Gamma is a constant, R, that also you have not learned, I suppose, that also constant. That is the M molar mass, T absolute temperature. Such a formula you would be getting later. Don't worry, I just gave you to understand when T is high, V also high, but it is inside the square root. But anyhow, when T increases, V would be increasing. That is square root is there for M also. Now let me to go for question number 2. The standard symbols for some devices used in circuits are given below. Label RTUWX. This is a diode. TWX is the one they are asking, right? Anyway, I will write. T. So your resistance that will depend on the light intensity falling. Light intensity falling. You are using such thing. Have you seen some switches operating in night time automatically that will give the bulb get automatically switch on in night, but daytime it will be switch off. Such one. Therefore, they are called LDR, light dependent resistor. U, it is a capacitor. W, if you say properly, it is NPN transistor. Otherwise, you can just say transistor. So how to recognize from the middle, there would be a certain arrow. This is where you use the arrow. If the arrow coming to that side is a different to the one we are using the arrow to the outside. The arrow will be always from P to N. So that is the current direction, P to N, forward bias direction. Now when this is PN, and there also you have to start with the N. So we call this is NPN transistor. So this is a variable resistor. There are different type of variable resistors, rheostat, resistance box. We have one called thermistor. They have not given the symbol. Thermistor means with the temperature that will change. Resistance would change with the temperature. I don't know whether you discussed during your syllabus. Thermistor is a symbol for thermistor. But if I have not discussed, don't worry regarding that, because that won't be coming. Full circuit constructed in laboratory are given in 1, 2, 3, 4, which standard symbol sell 1.5 bulb of cells of 1.5 volt. Bulbs 2.5 volt identical diodes and switches have been used in a circuit. So these diode, it's supposed to be LED, light emitting diodes. Then only it would be giving the current. I have only 1.5, right? Cell would be 1.5. So what is the issue with that? So this will be positive, this is negative. And here negative, that is positive. If you fix negative, positive interchange, you won't be getting a proper current flow. Net potential gap would be 0 here. Terminals are not properly connected. We call series connection of cells positive, negative, positive, negative. Then it is properly connected. Negative, positive to be connected. This is the bulb. Here 1.5 volt. There also 1.5 volt. And this is 2.5 volt. 2.5. The 1.5, 1.5, it is 3. So you are giving enough potential for this because you need 2.5. So you are getting more than 2.5. So it will be working properly. A bulb of 2.5 volt and identical diodes and switches have been used in the circuit. So they I have not used any diode, right? Because the diode also supposed to use. How about this? The proper direction of current flow to that side. But how you are fixing this? This is the positive side. You are going to send the current there. But now diode connected it to the wrong side, wrong orientation. The current won't flow. This will not light up. Why, sir? This will allow the current only to that side. But this is trying to send the current to the opposite. We call diode is reverse bias. Reverse bias. Therefore, you won't be getting a proper current. So there, but only thing, this will light up, right? Here, it won't, no light. This will light up. But again, here, no light. And you are having another circuit. That is the one I drew before. So of course, this one I have given direct. They have fixed 3, right? Good. 1.5, 1.5, 1.5. So if you have alternative, that means if current changes, still that current direction changes, still this will light up. That bulb, yeah, when you fix like this, definitely it will light up. If you interchange everything, still it will light up. So that is what we call alternativeness, right? If this is a direct one, always we are sending the current to one side, then it will definitely light up. How current goes, son? This is the proper direction. It won't go to that side. I here, I there. Now it will be going to this side. It won't go because this is reverse bias. This is the direction of current flow coming up until this. It's not that direction. Again, it won't go to that side. By it is already reverse bias. This is the current flow. Write down, relating the potential difference, the conclusion that can be reached through your observation in 1, 2, 1 and 2 in above. 1 and 2 mean these two. What is the conclusion? If you interchange the direction of cells, it won't work. The net potential would be 0. Their net potential is 0. Therefore, bulb will not light up. When you fix series mean positive, negative connected. Your potentials are getting added. Now it will light up. Bulb would light up. Through the corresponding output wave pattern in figure B, voltage with time for B. Figure B, that is for this. So instead of that one, if you give alternating, I would draw there, right? And it is B. What if I draw one below the other? So let me to insert such an alternating current. Now here positive when this is going. Therefore that it will allow to flow. But to the other direction it won't. Why? When this is negative mean it tries to send the current to the opposite side. The diode won't let it to flow to the opposite side. We call it is reverse bias. If it tries to send the current to the other side, it is like I'm fixing my cell. This is the cell I had. If I fix the cell to this orientation, current won't flow. Why? So to that direction. This is reverse bias. It would be acting like a reverse bias. Open switch. Open switch. Now they have given alternating supply. When it is positive, yes, son, then it will be flowing through this. If the potential is high, automatically my current also high. there won't be any current flowing as it is negative. From the device TWTUWX, which can be used to smooth the output current in the new circuit relevant to see. So remember I said the capacitors are used for the smoothing purpose. So what is the capacitor? It is U. U. Capacitors are used. So even for the filtering, signal filtering also capacitors are used. Smoothing capacitors are used. Smoothing and filtering. The two, I would say, usages. Two usages of capacitors. One is smoothing, the other one signal filtering. Right. Now let me to take essay questions, part B. Part B questions. Here question number 3. It is necessary to be vigilant and obey for road rules when using highways. So what are the rules that you have seen? One thing, speed limit, right? Speed limit. Highways. So that is the main one. Even you would see road narrowing. If you get any bridges, when we say highways, of course, so we won't be having any pedestrian crossings, isn't it? But in our normal road, we would be having pedestrian crossings also. But another one you might have seen a sign drawn like this, some rocks coming down. And in some places, some animals The boats are the animals. So you have to be vigilant. You have to be careful. Why? That is for your safety. Safety. So why? When you drive in highways, so your speed is fairly high. You cannot stop at once. You cannot stop at once. Why? When you apply the brakes, it takes a time to stop. During that time, you would be traveling. If you stop at once, very like high brake applied, so there would be a possibility you will be, otherwise you have the seat belts. That sign also there, sir. Wear seat belts. While you are driving in highway, seat belt is a must. Otherwise, when you apply the brake, you will be going, the windscreen, you will be going out. So generally, the road curvature in highways, it would be fairly high. Let me to bring you some additional information because I was there while the constructions are being done for our southern highway from 32 kilometer to 66 kilometer southern highway, and our road radius, the bend radius is 2000 meter, otherwise 2 kilometer. That is why you feel it is almost straight. For that portion, this is the value we kept. So even while you are traveling on such a curvature, so you need to have a certain force towards the center. Centripetal force required. Otherwise, so you are slipping outside. So there would be a possibility of hitting to a even with another vehicle or otherwise to the wall at the corner, depending on the bend direction, right? Even you might go out of the road. Now, all these limitations are brought to ensure your safety. Why? When you have a fairly high speed, you cannot stop at once. You need to travel considerable distance to stop, to minimize high impulsive forces. We call it is impulsive forces. When you have a high impulsive force, it is bad for your body. That is the reason you have to be very much vigilant on those, say, speed limit, the other, because if a certain rock comes and stay in front of you, otherwise you have a fairly low speed, you will not able to stop it. You will hit with that. How they asking questions. It is important for driver as well as the passenger to wear seat belts. Yes. In a vehicle when traveling on a highway, what is the reason for that? Seat belt will help you. Seat belt will help you to keep the passengers attached with the seat. Right? Passengers attached with the seat. Minimizing impulsive forces. Minimizing impulsive forces. When sudden brakes are applied, when sudden brakes are applied. Write down Newton's law of motion, which connects to the answer you mentioned, one above. So how the Newton's laws are going to connect with this? So what are the laws we are having? We have 1, 2, 3. First one. So if you move with a constant speed, there won't be any. Otherwise, I would say the other way around. When there won't be any external forces are acting, the object would be going through a straight linear path. Now think, you are taking a bend. Is it a straight path? No. So you need to have an external force to take a bend. That is why we cannot take sharp bend when the speed is high. You need to have a very high external force. As far as you are going with straight path with constant velocity, no external force. But otherwise, if you are going to change your speed, then external forces applies. Otherwise, if you are going to turn without a straight path, still external forces are applied. Now I would say even second law, that is rate of change of momentum, that is equal to the external force applied. If you are having very high external force, if it is required, you feel uncomfortable. If you have to change the speed quickly, your rate of change of momentum would be high. So even second law applies. Second law application. If speed changes quickly, higher external force applies. High external force applies. Even I would say third law applies. And what it says, every action has a reaction. So if you hit, when you apply the brakes, say no seat belt fixed, you will be hitting to the windscreen. Your head will knock with the windscreen. Then what will happen? You are applying a force to the windscreen applying a force to your head. Every action has a reaction. You hit with the windscreen, you are hitting to the windscreen, a windscreen would be applying a force to your head. Newton's third law. The displacement time graph for motion of a vehicle A, which travels on an expressway from beginning to the end at the maximum permissible velocity given below. Here, it has been assumed that the expressway is horizontal and it is in a straight line. Answer the following questions using the graph. Right. They have given displacement time. Variation linear. It is in meter. Time taken 1000 seconds. What is the length of the expressway from start point 0? Find it is going that much of a distance. Part 3A. Length 27 1000 meter. Calculate the maximum permissible velocity that a vehicle can be driven in the expressway. So assume it is going with the maximum permissible speed. Then I suppose to calculate speed here. Delta S divided by delta T. What is the change of distance? 27,000 divided by time 1000. 27 meters per second. Part 4. In heavy rain day, the drivers are advised to maintain 15 ms minus 1 as the maximum velocity for the vehicle. What is the driven to the expressway mentioned in, what will be reason, right? Maximum velocity for the vehicle that is driven on the expressway mentioned in 3 above. Yes, that is the data given. Yes. What is the main reason for advising drivers not to drive the vehicle at a higher velocity than velocity when heavy rain exists? So what is the change? So when you apply the brakes, what supports you to stop the vehicle? It is the friction. When you apply the brakes, what would happen? Son? The tires, you prevent it is rotating. Therefore, it is the friction which will give the force to stop your motion. While it is raining, your friction coefficients are very less. Friction that you can generate would be less. Why? It is slippery. We call it slippery. Therefore, the difference, dry day and a rainy day. In a rainy day, friction force reduces. When force reduces, I can stop at once. So I suppose to maintain lower speed. Otherwise, I would be having more risk. I will hit with another object or a vehicle. So they're asking, what is the main reason for advising the drivers not to drive the vehicle at a higher velocity when heavy rain exists? You can write while it is raining. The friction forces on the tires. Friction forces on the tires would be less compared to the other days. Therefore, driving with high speed would bring more risk to the passengers. Explain scientifically your answer above. you can say the possibility of having accidents, the possibility of having accident would be high. As friction generated on the tires, as the friction generated on the tires is low on rainy days. On rainy days. Part C. On a heavy rain day, the motion of a vehicle B which travels from the beginning to the end of the expressway mentioned in one above was follows. It starts from the rest, uniformly accelerated for 10 seconds and acquires maximum velocity 15 ms minus 1. Thereafter, it travels the same velocity for a certain time and then last 10 seconds, it uniformly decelerated and come to rest at the end of the expressway. Including the given information, draw a rough sketch of a velocity time graph for the motion of vehicle B. Starting with zero velocity, maintaining constant, and stopping. The maximum speed maintained 15 ms minus 1. Time taken to reach to that 10 seconds. And if I say this time is t, here 10 plus t, 1, say t1. Another 10-second taken to stop it. Therefore, 20 plus t1 from here to there, again 10, right? Again, how I took this time gap, t1 second. That time gap 10, this time gap also 10. So this is the final time I have marked. Find the total time taken by the vehicle B to travel on the expressway. So what is the total distance? It is this much. So I can write total area here is equal to that much. Total area. Let me to write area. How? This triangle plus that triangle and this rectangle. Half. This is 10. Height is 15. 2 of this. 2 of this. These two. Plus time is t1 into height is 15. These two together, it is equal to 27,000. 2 cancels off 150. T1 into 15 equal 27, 26, 850 divided by 15. Divide that by 15. 1790 seconds. I wanted to they had asked total time. Find the total time taken. Yes, not that. I want this total time. So total time. I am having that much of second plus 20. I will give in terms of second. That is all right. You can convert it into minutes or hours. If the mass of the vehicle 3000 kg, find the momentum at the instant when it travels with the maximum velocity. So what is the momentum? MV product. 3000 into maximum velocity 15. 45 kg ms minus 1. When drivers are driving vehicle, it is important to pay attention to the side mirrors in front of the vehicle for prevent accidents. What type of curved mirrors I use as side mirrors of the vehicles? So what is the requirement? So you need to see a large area to be seen. Therefore, when they are getting closer, even from a far distance, you will realize a certain object getting closer to you. Therefore, what is the type of mirrors that you are using? It is a mirror, definitely, right? Mirror. Silver applied in this side. We call it is convex mirror. How does pay attention to those mirrors contribute to prevent road accident on the vehicles are driven? So why on a convex mirror, large area would be seen. Would be seen. Then the vehicle they are getting closer can be identified much in advance. The vehicle they are getting closer can be identified much in advance. Because especially some this particular accidents are taking place while you are turning or while someone else turning. If all are going straight to the same direction, no issue. The while turning, you will realize if someone coming closer to you, because you can see through the mirror, a large area would be seen. So you must pay the attention to the mirror. Even while overtaking, that will help you. The mirror. Let me to take next question. That is question number 4. Question number 4. It is stated that the voltage of a motor car battery is 12 volt. This battery comprises 6 electrical cells. Voltage each 2 volt. So that is the reason we call such cells are accumulators. Now each cell 2 volt and 6 of such we combine together to create 12 volt cell. Now you will see there are, because in car batteries you will be using the lead and sulfuric acid. For each cell you can pour sulfuric acid separately. They are separated, but they are connected side in series. Now altogether 12 volt is generated. Using circuit symbol, draw how 6 cells are combined to make the battery. There are 6 of such. So symbol wise that is enough. But this is the positive, negative, positive, negative. Each one 2 volt, 2 volt, 2 volt. Net effect. So this is the one they asked, right? I'm drawing the net effect. Positive, negative, 12 volt. The 2 headlamps of motor car are identical and figure indicate how they are connected to a battery. This is your battery. Negative, positive, that is how they have given. The current would be flowing to this side when this is switch on. Name how the 2 lamps are connected. So what is the arrangement? We call it is parallel connection. Parallel connection. Shown in the diagram, the other way. So in a diagram, the other way of connecting bulb, 2 lamps, bulb. This is your battery. You can connect them in series, right? This is a series connection. See, what is the advantage of connecting 2 lamps bulb as shown in the given figure? So what is the advantage? You have 12 volt supply there. Now here also for each bulb, 12 volt supplies, 12 volt power supply would be applicable. Now what is the advantage here? For each bulb, 12 volt power supply is given. For each bulb, 12 volt power supply is given. What is the disadvantage there? Then your voltage. If you are having 12 volt there, 6 volt on this, another 6 volt on the other. It is shared equally as they are identical. The resistance of each lamp bulb shown in the figure 2 ohm. So this is 2 ohm. That is also 2 ohm. That is what they say, right? Each one 2 ohm. Calculate the equivalent resistance of 2 lamps. Two ohm, 2 ohm. I can calculate the equivalent resistance simple R as they are parallel. Reciprocal addition would be equal to the reciprocal of the resultant 1 over 2, each one 1 over 2. So out of 2, 1 over R equal to 1. Take the reciprocal, R also 1, 1 over 1 over 1, that also 1. Well, you can say this is equal to 1. Find the current flows through one lamp bulb when the circuit is put on close in the key. Right. So now I will calculate the total current and thereafter each it will be sharing equally. So I can draw this diagram. This is 12 volt, right? They are in parallel. This is 2 ohm. That is 2 ohm. I had simplified this. $12 volt, 1 ohm. I would say this is going capital I. The capital I would be sharing equally there. Apply V equals IR. V 12. I capital I. R 1. So capital I equal to 12 ampere. 12 ampere coming from this. 12 ampere coming from this. And it will be shared between these two. 6 ampere and 6 ampere. Calculate the current flowing through the other bulb if one bulb is get burned. And now this is going to get burned. Now it is not there. I1. This is 2 ohm. Here 12 volt. So let me apply V equals IR for this. I can give you answer quickly, but let me show you having calculated. So 12 volt would be applicable there. I1 going through this also. R will be 2. So my I1, 6 ampere. So I'm having 6. Now come back again. I realize this is 6, that is 6. If this is burning, it is getting disconnected. But there won't be any change for this. So 6 ampere, that will continue to flow. No change on this. That is the same thing we are getting there. When it is parallel, if one gets burned, the other one unaffected, provided no internal resistance for that, right? Otherwise, there would be a small effect. Yes, son, it is the end of question I have selected here to discuss with you. And if you have anything, any special thing to ask, I can answer. And
Sir, can you teach the direct motor current that when using Fleming's rule, left hand rule and right hand rule?
son, could you please repeat your question? Yes, I will. Please repeat your question.
Sir, can you teach that the DC motor, Fleming's left hand rule and right hand rule that we are
Sure.
using?
Okay, good. Okay, good. Yes. So the question is to explain again right hand rule and the left hand rule. There are two cases. Let me to remind. Right. I will take this side left. Here right. All right. So there you have a machine, two inputs. You're supposed to give two inputs. What are they? I would say inputs. So you're supposed to give current and magnetism. We call magnetic field. What is the output? Output force. So current is created with a cell, otherwise electromotive force. We call potential of a battery, the word is electromotive force, EMF, electromotive force. Electromotive force, it is the potential gap we refer, right? Would produce the current. The magnetic field should be there. These two together would generate a force. So when you get a force, if it is allowed to move, sometimes you are not allowing that to move. It is fixed. Still force available. If you allow that to move, then you will be getting a rotation or movement, right? Movement. So this particular part, application, motor. Why? Inside you get magnetism. You connect a cell. So this is rotating, and it is the one we call motor. This is called motor. And this is the right hand rule. What you are to give, the motion to be given. And magnetism to be given. What is the output? EMF, electromotive force. It will create a current. So the EMF will create the current if you provide a closed path. If you provide a closed path, then only you will be getting a current. Magnetism mean field. So this particular application, this is the opposite of motor. So you rotate this. From the terminal, you will be getting the current, EMF. You rotate. Inside, magnetism available. This is called generator. So this rotation that can be done in many ways. Practically, we use hydro. The potential energy is used to rotate the turbine. Turbine would be fixed to that point. While it is rotating, how water would be going through the tunnel. At the end of the tunnel, we will be fixing the turbine. Then it will start rotating. When that rotates, electricity generated. That power called hydropower. And we have few more: diesel power, coal power. And all those cases, what we are doing, we burn the fuel and we take water vapor. The heat is used to generate water vapor. That vapor would be sending high pressurized vapor. We will be sending through the generator to rotate. And with that rotation, again, we will be getting the EMF created, generated. Therefore, nowadays, even few months back, we are experiencing experience regarding the power cut simply because we are not having fuel. What is the reason? All these turbines, or the majority, I would say, majority of the turbine in Sri Lanka, it is rotated using the fuel. Whereas we are not having the fuel. We are supposed to bring them from outside. So what we have, it is the hydropower. While it is raining, water can be stored and that can be utilized. Therefore, don't worry, son. If we get zero coal and zero diesel, still we will be getting few hours of electricity from this hydropower. But unfortunately, if you take the total demand, so that would be varying, but it is nearly 2,800 gigawatt. Megawatt. Right? This much of megawatt. So see, we have Norachole coal power plant giving straight away 900 megawatt, right? How you get this? See, straight away 900 from one power plant. Total hydropower, that depends on the water storage that we are having. We will have to release the water. If we are getting throughout uninterrupted water supply, then we can generate a lot, but we are having dry season. During those dry season, we will be getting less. Now it would vary. Some, say, period of the year, we produce nearly 1,500 megawatt of hydropower. This is coal power. And diesel power would be the balance. The reason hydropower plants, and we can stop within maximum 10-minute period. Only just 10 minutes. So this coal power plant, we need stopping and starting. The time gap will be nearly 2 days. Diesel power. This is diesel power. So for that also, more than 10 hours, we cannot stop at once. We cannot start at once, because so we'll have to boil water having burned the fuel. That is the reason. The water, just you are sending the water. So this is the quick. You can operate quickly. You can stop quickly. Now we try our level best to keep our storages. That is how we maintain. So when dry season comes, that value will be very less. So we need from diesel and coal power. Now this drops to sometime even 500. So that is the, I will come to this power crisis, having explained these two, because I have some more to explain regarding the left hand and right hand. Right. This is the right hand rule. This is called generator, otherwise dynamo. So how we are using, we have our middle finger, forefinger, and the thumb. Middle finger, it is for the, you have to give the current input, right? Current. Here magnetic field. Now this is the force. If you take your right hand rule, it will be 100% similar to this one, son. Let me to show you. So there you get the force. Due to the force, it will rotate, right? Therefore, the motion would be with the thumb. The middle finger, here also field, there also field. Sorry, this is the forefinger, right? Forefinger field. The middle finger, there you get current. but the current is generated with EMF. Therefore, it is similar. EMF is coming there. EMF. That is the middle thing. The story I gave you, because don't interchange those two. Very important to keep in your mind. This is a motor story. Left hand rule, motor. And dynamo, that is the right hand rule. Dynamo application goes for the right hand rule. Yeah, I was just telling our power crisis, because another month time you will have to face this issue a lot. So exactly when I was studying for O level, for your exam, right? O level, I didn't have electricity power to my place, to my house. Sunny, on those days, before year 2000, only 25% of the total population in the country, we had electricity. Only 25%. And whereas we didn't have cell phone, because cell phone came nearly 99, 2000, 2001 likewise. No cell phone. Computers, very less. Very less. Because when I was doing my O level, no computer such. No phone at all. No internet at all. Nothing. But quick change, right? Quick change. Year 2000, the government took a decision to give the power as much as possible. Now they had to make 4 times the power they had. They were enhancing, expanding the power lines and everything. But so we didn't have only very small addition to the hydropower sector after year 2000, because all these projects in Mahaveli, under Mahaveli River, they had already completed. The only very few came. Now, what were the alternative solutions? So they went for diesel and the coal power. So that is the mistake they did. So that is why everyone says the mistake starts after 2020, after 2000. This crisis is coming due to the decision took after year 2000. So what did it? They started using a resource that we are not having. They expanded on the resources that we supposed to collect from outside. Therefore, governments has taken loan, right? They have taken loan to implement projects, raw material outside, and it is on loans. So all these power projects, that is on loan. So at that time, of course, we know the solar power, they were not much popular. But if they had taken solar power, so the particular raw material, that means what we need, the sun, right? So it is with us. Therefore, we are not facing such an issue. Because we have power plants, but the problem is we are not having diesel or coal. Why? We don't have a foreign currency to purchase them. So we have capital cost as we have already constructed them. And we have the second issue, we don't have resources inside. Therefore, they went on expanding because power demand was very much high because of the cell phone and the computer. And everyone using more power, more electricity. But the generation without the resources that we are having. Now, if we are thinking now, definitely we should reduce our power usage. How? So we cannot stop our, because we cannot work without the cell phone and we cannot work with the computer, right? So at least so we should find alternative solutions for preparation of meals. Why? The power that we are getting through gas is just heat only, sir. It is just heat. Therefore, that if we find alternative solutions, we can utilize our foreign currency at least to generate electricity. Even these days, remember, though the power is not cut, and please understand, it is with the diesel power. They are burning diesel, the one we got. They are using to generate electricity. Our power interruption, the length of interruption would be very much high another few months later because of this. So they should have, they should have thought on this, how we are going to find this. The second thing, it's all right if we have generated foreign funds using them. Because if we are getting foreign currency due to the resources that we are using, then it is all right. But we are generating, it's very less. Can you think of any foreign currency earning methodology or some factories that is generated after year 2000? No, sir. So that is the biggest mistake. Therefore, we are badly affected because of that. Now, you and me both would be facing those issues. Even I work in road sector, so I am very much I would say familiar with this power generation, because even I have developed, I have constructed, I have given consultancy on my own to have these power projects. If you wish to see, because we were going with students last 2 years or 3 years, like we didn't go because of many other issues. Otherwise, I have taken my students to those power stations. You can go very close to those places to see how they are generating power. Even last December, I went, but I went with my family, not with any students, to Moragaha, where Moragaha Kanda, right? There is Moragaha Kanda power plant. That is the recent power plant that we have done. So that is for 25 megawatt. Moragaha Kanda. There are 4 machines, 7.5 of 2 and 5 of 2. 2 of such. Moragaha Kanda. I went last December. So we have a few more power hydropower plant possible locations. There are very few more, but still, if we complete them, still only a very few addition to our national grid. But the best solution is diverting to solar power at this stage, right? At this stage, because our entire Colombo, we are having roofs. And if you put on each roof a solar power plant, so definitely Colombo as well as some more areas, we can handle with the solar power. Because this is the suburb. That is where we are getting most power demand. So we will able to manage a lot. Advantage, we have a fairly high capital investment, but however, running cost would be less as we are having the resources. Okay, good. Son, having said that, some information regarding the power, I will wish you all the best for your O-level exam. And after that, I know you were supposed to select A level. Some very important thing I need to tell you, and that is, son, please study as much as possible, because the gravity on your shoulders would be very much high. Why? Your grandparents and your parents, what they are going to offer as Sri Lanka is not that easy for you to take onto your shoulders. So otherwise you learn, definitely it will not be easy. But if you learn, definitely it is very simple. I will tell you, son, that also I need to tell you, son, this crisis, definitely we can handle. I will tell you the easiest method, and be very much happy as you have studied in English, because, son, when you compare with other languages, there are many countries that they are using English as their communication language, and you have more opportunities. But try to get the opportunity to work in another country, and that will make foreign currency for us. Then I don't mind if you get the opportunity, you can migrate. That's all right, sir. No issue at all. Because if you come for a 1 month every year, that is more than enough. Sunny, minimum of 400,000 people going for O level. Right? 400,000 people going for O level. So if you take 100,000 people going abroad every year, again I'm telling you, 100,000 people going abroad every year as professional workers. That means you should have a set, say, a professional work, not that you are going to give you a labor service. But maybe you are a IT person, maybe you are an engineer, maybe you are a doctor, maybe you are a machine operator, even, because even machine operators you would be getting high salary, but some machine operators means not that driving job, right? Because there are special machine which is operated with computer softwares. That is how it is working now. CAD machines, computer aid systems. So then, if you able to send $100 a month, you will be getting this much of people, $100 per month. That will make big amount. So likewise, if you send for 10 years, Sri Lanka would be very much prosperous. And that is what India has done. India faced the same issue in 1991. What they did? So they taught as much as possible IT for Indian people. Therefore, world everywhere, Indian workers generating foreign currency for them. That is how the India got developed. So compared to the Indian population, Sri Lanka is a very simple population. So it's nothing. You go with Indian people. Yes, we would be definitely get enough currency. Now my request, and as much as possible, try to get the opportunity to go abroad. So even later, I will give you more, say, advices on this. But at this stage, doing with English medium, learning this, because science, maths, commerce, everything is the same even in other countries. What we are learning here, it will be same as all the other countries. And you will be having more opportunity. Son, thank you very much. With that, I'm going to wind up with this. Let me to check, perhaps Jagat sir would take back. Yeah, let me to hand over to Jagat sir, and he would have a word with you. Right. Thank you very much, and kind cooperation for me to discuss my paper. I1.
Thank you very much, Mihir sir. On behalf of all the students, I would like to thank you again, and very valuable advice, as well as I think all the students benefited from you today to improve their marks, especially out of these three areas. The hardest part for many students, they find physics part difficult, and we have two more seminars: Friday night biology seminar and Saturday night 14th, same time from 8 p.m. to midnight, chemistry seminar, the final seminar. And so you can join with Mihir sir, anyone of you are planning to do A-level bioscience max, because he is doing A-level English medium, advanced level physics, and he's a very good physics lecturer, and you can join, and I'll provide more information about that in the future. So first you have to face your oral exam and go for the best results, and then you can start your A-levels also from June. I think English medium science subjects, they are going to start from June, and you are finishing the exam I think 1st of June, and the exam also now confirmed 23rd you're starting. And all the very best for everyone, and I hope to join with you all again Friday night with the biology seminar. Until then, take care. God bless you.